There are, of course, more types in Swift than just strings. In the previous video, we tried to add a number to a string, and that didn't work because a number is a totally different type. In fact, a couple different types. Let's take a look.
Let's add a section marker to our playground to mark off our next set of types. Now we can use a single line comment like we have, but that will get lost in this sea of comments. So let's jazz it up a bit. Remember that we can create a multi-line comment by starting with a / and then an asterisk. And then you can do whatever you want. So in here we'll say integers. Okay, and then to close it off, another asterisk and a / again. Okay. As you might have guessed from our next section marker, the next type we're going to work with is integers. Just a refresher from math class, an integer is a whole number like 42 or -23. Now, our favorite programming language is Swift, so let's declare a string and assign the value to it. Let favorite programming language equal open double quote Swift close double quote. We've already worked with integers not too long ago when we assigned it to our street address. Let's declare a new constant called year and assign it to the year Swift was created. So we'll say 2014. The value 2014 that we just added is an integer and is represented by the type int. As beginners, that's really all we need to know. Under the hood, Swift does some extra stuff depending on the size of the number we use, but we don't need to worry about that for now. But whole numbers aren't the whole picture, pun intended. What about partial numbers like decimal values or fractions? How do we represent those? For that, we have a separate type. So let's add another section marker, and we can just copy this one. And now we'll say floating point numbers. We might need to extend this out to make it look nicer. There we go. Okay, so another math refresher. Floating point numbers are numbers with a fractional component. So numbers like 3.1415, more commonly known as pi, or a -100.5, anything where you need a decimal place. So we have the language Swift released in 2014, and we've used an int value to represent that. When Swift was released, the version number was 1.0. But since then, many improvements have been made. At the time of this recording, we're at Swift 3.0, almost 2 years later. So let's record that version number. We'll say var version equal 3.0. By adding a decimal place, Swift knows that we're representing a floating point number. Now you'll notice here that it doesn't seem to show it as a floating point number. It looks like a whole number, but that's because it knows that we don't really need the 0.0 because it's simply 3. If I were to do 3.1, you'll see that that value shows up. In Swift, floating point numbers are represented by two different types, double and float. A double can represent a value having at least 15 decimal digits, while float can be as little as 6 decimal digits. The two different types again have to do with the size of the number and how they're stored in memory. And Apple's guidance on the matter, and basically all you need to know for now, is to use the double type unless you specifically need float. Okay, so let me add a few comments in here to specify the type so it's easier to remember. So beside the year, we'll add a comment and we'll say this is of type int. And notice that because I'm adding the comment after the assignment of the value to the constant, this is not commented out. And in here, beside this version, we'll say double. Now you'll notice that I use var to declare the version variable rather than a constant. Remember how I said use constants unless you need to represent a value that can change. Well, the version number can and has changed many times with the Swift language, so we represent that with a variable. Okay, there's one more type that is a number under the hood, but we don't really treat it as such, and that is the Boolean type. So I'm going to grab this again, this section marker, copy it, and paste it down here, and we'll say Boolean. Boolean values are really interesting and they're used to model true or false. So let's add a constant to say that Swift is awesome. We'll say let is awesome equal true. In usage, Booleans are represented and written with the keywords true and false, but it's actually a binary value under the hood. Now, binary means that it is either a 1 or a 0. So this true or false that you see here, Swift actually reads that as a 1 for true or a 0 for false. The type for Boolean values is bool. Okay, we've introduced a couple new types, so let's recap everything so far. First up, we have strings. The string type represents text, and the syntax is text enclosed within 2 double quotation marks. Strings can be manipulated in different ways. We can add strings together to concatenate strings, and we can use string interpolation to create strings by mixing in strings and other types. Next, we have integers represented by the type int. The int type represents whole numbers like 50 or 100. Then we have floating point numbers represented by either double or float. A floating point number is a number with a decimal value like 3.14 or 9.8. The choice of double or float is best left up to Swift to handle it for now, since it depends on the size of the number. We're going to default to using double if we need to specify the type. Finally, we looked at bool, which represents Boolean values or how a computer models true or false. Under the hood, a 0 is false and a 1 is true.
This brings our tally of the different types we know up to 5. Awesome. I'll let you finish this video and tackle a code challenge, and then we'll talk about type safety and type inference.